simplifying radicals, which we talked about a little, but this one's an expression. There's lots of terms in this, okay? So for this one, what we actually want to do is we want to get radicals that are the same, like root 5s in each of the terms. So technically there are currently 1, 2, 3, 4. These pluses and subtraction signs, they separate terms. So there's 4 terms here. So we actually have to group like terms, okay? So we're going to try to break this 24 into a simplified one. So I know 24 is actually root 6 and root 4. 27 can be broken into, I bring down that plus sign, okay? 27 can be root 9 and root 3. Bring down the subtraction sign. I'll do those in red so they look a little different. Bring down the subtraction sign. We still have that 2. 20 can be broken into root 2 and root 10, okay? And that's a plus sign, plus, and 3 just kind of comes on down, okay? We're going to do this. We're going to work on each one individually. Then we're going to start putting them together, okay? Root 4 is actually just 2, okay? So that can be 2. And then root 6, I know the 2 values. They're 2 and 3. They're the only 2 multiples of 6. And I can't break 2 and 3 down. So I would have just multiplied them back together to get 6, okay? Root 9. I know what root 9 is. Root 9 is just 3. And root 3 is a prime, so I can't go any deeper. So that one's okay. Here I can do a little something that will help us out, actually. I can break 10 into another set. So root 2, 10 can actually become root 2, root 5. So what's neat there is I built another root 2. So that's going to help us do some simplifying. And then plus the number 3. The other ones are going to stay the same. So the very first term is still 2 root 6 plus 3 root 3. This one's going to become 2 times, that's actually 2, root 5. 2 times 2, it's going to give us 4. So I'm going to rewrite it again, a lot of tedious stuff because I know I'm only changing 1 per line, but this is okay. That's going to become 4 root 5 plus 3. When we look here, evaluate, simplify the following expression. That is as far as I can go in that expression, actually. It's a really weird one to work with. Let's say I want to continue this because there's more to be learned. The reason we can only go so far is all of the roots, there's no root here, but so that one's just a constant. They're all different. I can't actually combine them. Let's say, I'm going to shrink this a little. I'm going to say, what if, because I don't want you to get confused in your notes, what if this was the answer? Oh, I don't know. Let's say it was 2 root 6 plus 3 root 3 minus 4 root 6 plus, I'm going to say 3 root 3 again, okay? I've changed the question just a little. If you notice, I have a root 6 and a root 6, and I have a root 3 and a root 3. These are like terms. I can actually do stuff with them. In fact, to make it a little easier for us, I'm going to say, have you ever seen anyone do this? Let x equal, so let's say let x equal root 6 and y equal root 3, okay? I'll rewrite this again. Now it becomes 2, what color did I do it? 6 is red, okay, so 2x plus 3, green will be y, minus 4x plus 3y. This is a little easier for us to work with. We've seen polynomials before. Which 2 can I put together? Negative 4x and 2x, sure. So what's negative 4x plus 2x?
Negative 2x.
That's right, negative 2x. And what's positive 3y plus 3y?
6y.
That's great. So that's done, except that there's no y's and x's in this original. So we do have to substitute back. So in this case, we'd have negative 2, and because x was root 6, we substitute back in root 6 plus 6, and y was actually root 3. 6 root 3. So your final answer here would look something like this. Negative 2 root 6 plus 6 root 3. Now, the question we did had no radicals the same, so I couldn't actually simplify it any farther. It was an odd question for whoever was asking us the question to choose. Usually you look for terms that end up with the same radical so you can do that final step that we did in our what if there.